Hello chemistry students, this is a review for our quiz over Objective 7A and 7B1. This is going to cover three things: the s'mores lab, which was an introduction to stoichiometry, limiting reactant, and excess reactant. We're also going to cover the law of conservation of mass and how to support that law with a chemical equation. And we're also going to do a couple of mole problems, and all of this is covered on our first quiz. Okay, let's get started with the s'mores lab example. So here I have our equation that we need in order to make one s'more. Question number one says, if I want to make 3 s'mores, how much of each reactant do I need? Well, in order to figure that out, all I need to do is multiply every reactant by 3. So I'm going to multiply the coefficient for every reactant by 3. So this means I need 3 times 2, or 6 graham crackers. I need 3 times 1, which is 3 marshmallows. And I need 3 times 4 chocolate pieces, which gives me 12 chocolate pieces. And if I have all of those ingredients in my kitchen, I can make 3 s'mores. Next, in my kitchen, however, I've only got 10 graham crackers, 20 marshmallows, and 12 chocolate pieces. So how many s'mores can I produce? So in order to figure this out, I just need to divide each amount by my coefficient in my equation. So 10 divided by 2 gives me 5. So with my 10 graham crackers, I could make 5 s'mores, as long as I had enough of everything else, but I'm not sure. Let's wait and find out. For every s'more, I need 1 marshmallow. So 20 divided by 1 is 20. So if I have enough of everything else and 20 marshmallows, I could possibly make 20 s'mores. For my chocolate pieces, I need 4 chocolates for every s'more. So if I divide 12 by 4, I can make a total of 3 s'mores. So if I take a look at my values here, I can make 5 s'mores with 10 graham crackers, but the problem is that I don't have enough chocolate pieces. I could make 20 s'mores with all my marshmallows, except I don't have enough graham crackers or chocolate pieces to make 20. And my chocolate pieces only give me enough to make 3 s'mores. So if I'm going to make entire s'mores, that means that I can only make 3. My limiting reactant then here are my chocolate pieces, because they are the ones that are going to limit the amount of product that I can make. If I make 3 s'mores, if I make 3 s'mores, that means I'm going to have extra graham crackers and extra marshmallows. These are my excess reactants. So for my graham crackers, if I wanted to figure out how many graham crackers I'd have left over, I would subtract 10 minus 6. Why 6? Because if I'm making 3 s'mores, I would need 6 graham crackers, and that means that I would have 4 graham crackers left over. What about marshmallows? Well, if I'm making 3 s'mores, I need 3 marshmallows, and I'm starting out with 20, and that means that I would have 17 marshmallows left over. All right, so that's it for s'mores. Those are just some little tastes of types of questions that you should be ready for. Now let's look at the law of conservation of mass. Using the equation below, demonstrate how balancing equations helps us to follow the law of conservation of mass in chemical reactions. Well, the first thing that you need to do in any chemical reaction that you're going to start with is you need to balance the equation. And so I'm going to put a coefficient of 2 in front of hydrogen and a coefficient of 2 in front of water. And now I have equal amounts of hydrogen and water on each side. And so let's just take a quick review of what the law of conservation of mass actually says. So the law of conservation of mass says that mass isn't created or destroyed in a chemical reaction. So this means that the mass of your reactants added together should equal the mass of the products. And we can check this out by adding them together. So the first thing we need to do is multiply the molar masses of the reactants by their coefficients and then add them together. So let's look at our reactant side first. Our reactants are hydrogen and oxygen. The molar mass of hydrogen is 1.01. And we have 2 of them. So that's what we're doing when we add 2 hydrogen atoms together. However, we'd have to multiply this by 2 because of the coefficient that is in front of it. So if we do this, we get 2 times 2.02, which is equal to 4.04. For oxygen, the molar mass is 16, and I'm getting that just from the periodic table, but we have 2 of them. And our coefficient here is blank, which means that we just have a 1. So 1 times 16 times 2 is equal to 32. So if we add 32 and 4.04, we get 36.04 grams as the mass of all of our reactants. Now let's look at our products. 1 mole of water is equal to 2 times 1.01, so that's 2 hydrogens plus 16, and that's equal to 18.02. But don't forget, we have a coefficient of 2 here, so we have to multiply 18.02 times 2, and when we do, we get 36.04 grams, and the mass of our products equals the mass of our reactants, and therefore, with our balanced equation, the law of conservation of mass is obeyed. Okay. On the next page, we have some mole-mole Stoich problems to look at. So the first thing that we have to do is balance our equation. And in order to get our equation balanced, I need to add a coefficient of 3 in front of magnesium chloride, a coefficient of 2 in front of aluminum chloride, and a coefficient of 3 in front of magnesium oxide. So the next thing that we need to do is translate our equation in terms of moles. What this means is that 3 moles of magnesium chloride plus 1 mole of aluminum oxide yields 2 moles of aluminum chloride and 3 moles of magnesium oxide. Next, we're supposed to write the possible mole ratios between magnesium chloride and aluminum chloride. And we need to explain what they mean. Okay, so remember that in a chemical equation, by using our coefficients, and magnesium chloride we'll underline in blue just so that we can see it easily, and then aluminum chloride will underline that in pink here. Okay, so we can say that 3 moles of magnesium chloride is equal to 2 moles of aluminum. chloride. Now that's not technically a mole ratio. We're going to take this equation and we are going to rewrite it in two ways. The first way is we can write it as 3 moles of magnesium chloride is equal to 2 moles of aluminum chloride. Or we could flip this around and write it as 2 moles of aluminum chloride is equal to 3 moles of magnesium chloride. And basically, what these two things mean is that 3 moles of magnesium chloride is required to produce 2 moles of aluminum chloride. Like so. Okay, these mole ratios are things that I wanted to clear up with you though, because we're going to use them in the problems. So when you're doing these problems, it helps to first identify what's given and what's wanted. So in number 4, if I begin with 4.8 moles of magnesium chloride, how many moles of aluminum chloride can I produce? Well, 4.8 moles of magnesium chloride, this is my given. And we are looking for moles of aluminum chloride, so this is what's wanted. Okay, great. Now, whenever you're solving these problems, going mole to mole, you first start with your given. So let's write 4.8 moles of magnesium chloride, and we're going to multiply that by one of these mole ratios. But the one that we're going to choose is the one that has moles of magnesium chloride down here on the bottom. And that ends up to be this formula here. So we are going to write 3 moles of magnesium chloride. Ooh, let me put that 3 a little bit closer so it's not so awkward. 3 moles of magnesium chloride on the bottom so that we can cancel moles of magnesium chloride. And then on the top, we're going to write 2 moles of what's wanted, aluminum chloride. So this is what's wanted, and this is what's given. And where did we get these numbers? These are the coefficients from our balanced equations. And just to make sure that you see that, here's the 3 in front of magnesium chloride, and here's the 2 in front of aluminum chloride, and that's exactly what we have here. Okay, so let's do some calculating. So cross out moles of magnesium chloride, and look at, we're left with exactly what we wanted, moles of aluminum chloride. So to punch this in your calculator, you're going to do 4.8 times 2, hit your equal sign, hit your division sign, and then divide by 3. And when you do that, you should get the answer, 12.5 moles of AlCl3, and then put a circle around it. Now remember, in order to get full credit on your quiz, you have to include the units, moles and compound. All right, now let's take a look at our last problem, number 5. If I want to produce 12.5 moles of magnesium oxide, how many moles of each reactant must I use? Well, we are given 12.5 moles of magnesium oxide, and moles of each reactant is what I want. But remember, like, look at this. This says each reactant. I have 2 reactants. My reactants are on the left-hand side of the arrow. So I need to do 2 calculations here. 1 for magnesium chloride and 1 for aluminum oxide. So I want moles of each reactant. Magnesium chloride, this is going to be one calculation, and then the other calculation is for Al2O3, aluminum oxide. Okay, so for moles of magnesium chloride, this is what I'm going to do. Start with what you're given. I'm given 12.5 moles of magnesium oxide, and I'm going to multiply that by the mole ratio. I'm going to put moles of magnesium oxide on the, moles of magnesium oxide on the bottom, and I'm going to put moles of what I want on top. What numbers go here? I need to consult my balanced equation. So my, I gotta go all the way up. My coefficient for magnesium oxide is 3, and my coefficient for magnesium chloride is also 3. So I'm going to use 3 for both of them. So I put a 3 here, and I put a 3 here. Now let's do our calculations. Moles of magnesium oxide get canceled. And now I multiply across. So I'm going to multiply 12.5 times 3. Hit your equal sign. And then we need to divide by 3. So hit your division sign and then punch a 3 into your calculator. And when you do this, and you can even see this by looking at your fraction here, but the 3's are going to go away, the 3's are going to be canceled, and we get 12.5 moles of MgCl2. So that's the first part of our answer, but remember, we have 2 reactants, so we need to do it again for aluminum oxide. So for moles of aluminum oxide, we start out with our given 12.5 moles of magnesium oxide times, I'm going to put moles of magnesium oxide on the bottom, and we already know that the coefficient there is 3, so I'm going to put a 3 there. And then on top, I put what I want, which is moles of magnesium, moles of aluminum oxide. And if I look up at my equation, having a problem sticking here. If I look up at my equation, I have no coefficient in front of aluminum oxide, so that would be a 1. So that's 1 mole of aluminum oxide. Let's do our calculations. Moles of magnesium oxide go away. Across the top, I'm going to multiply 12.5 times 1, hit your equal sign, divide by 3, and I get 4.17 moles of Al2O3. So what do these two answers mean? That means that in order for me to produce 12.5 moles of magnesium oxide, I need to react 12.5 moles of magnesium chloride with 4.17 moles of aluminum oxide. Okay, that is it for our review today. I hope that this helps. Good luck on your quiz. See you in class.